Okay, here's me trying to explain friction on ramps as simply and fast as possible. Okay, here are all the different symbols you'll have to know. This symbol right here just means that it's a single sentence. So this is the, friction parallel. Just all that. All right, well, let's get started. Friction parallel is the mass times the gravity times sine theta, which pulls it down the ramp, as we see here. Sine theta is right here. Once a ball is placed on a ramp, it is split into two different gravities, one pushing the ball down into the ramp and one pushing it slanted down. So we express this by mass times gravity times sine theta. F perpendicular, or friction perpendicular, is the mass times gravity times cosine theta, and this is the gravity that pushes it into the ramp. So with, again, as I said, it splits it up into two different types of gravity. So normal force is equal to mass times gravity. This is normal force right here, the N. It is mass times gravity times cosine theta. And it is the exact same as friction perpendicular. Okay. Friction is shown. So this is friction of opposing motion, F underscore little f right here. This is proposed as, F underscore little f times the, this little symbol here that looks like an upside down N is actually the coefficient of friction. So it's the coefficient of friction times normal, the normal force. Here, I'm sorry. My throat kind of hurts right now. So yeah. We get into friction. Friction it depends on how hard the surfaces press together and how rough they are. So they press together, that's N, and how rough they are is the kind of micrometer symbol it looks like, but it's the coefficient of friction. On a ramp, this is the equation given. It is the micrometer upside down N symbol, which means the coefficient of friction, times mass times gravity, which is 9.8, since that's the constant, times cosine theta. Okay, now here we get into more in depth. If friction parallel is greater than friction, or the force of friction, then the object slides. Or the friction force opposing motion, then the object slides. If F parallel is less than or equal to the friction force opposing motion, the object stays still. So here is the, where are we? All right. Yeah, okay. So here, the, this is like the, trying to put it into good words that I would understand. This is like net force, okay? And so if it slides, the net force is net force, one thing, and it's equal to friction perpendicular. Actually, what is this? What did I write here? What? I think that's supposed to be an A and an R. Okay. F parallel minus F underscore little f. The acceleration is A, as in the acceleration, and it's equal to the net force divided by the mass. And so here we can see we split them up into two parts. The force moving it down is mass times gravity times sine theta. This is sine theta right here. The force pulling it down into the earth is mass times gravity times cosine theta. Okay? Practice question you can do on your own. 5 kilogram block on a 25 degree ramp with the little upside down U is 0.3, okay? First, you find the friction parallel, which is mass times gravity times sine 25 degrees, since we're given a 25 degree angle. Then you find the friction perpendicular. Then you get the friction perpendicular, right? Then for friction, you get the 0.3 times 44.4, and it's equal to 13.3. I'm just running through this quickly because you know, YouTube, gotta keep it short. You basically just plug in all the equation. You find everything. And for comparing it to determine whether it slides or not, you get the friction parallel, and you compare it to the you compare it to the friction like comparison. And if we look back up here, if the force parallel is greater than the f little f, you know, it will slide. And here we see that it is. It is greater. Okay, so we get the net force, 20.7 minus 13.3. It's equal to 7.4. And the acceleration, we take the force, the net force, we divide it by the mass, and we'll get 1.48 meters per second squared. And so yeah, we got that. And that's pretty much it. You will go into more detail. This is just a very basic understanding. I tried to do it as fast as possible because, yeah. Thanks for watching. Hope you learned something.